All right, guys, so what we're looking at today is chapter 1.6, a parent of libraries, I believe. A parent library of parent functions. So we'll be talking about a few different things when we look at this here, identifying graphs, how they work, how they look, just some different properties of them. Now we have the first one is linear and squaring function. One of the goals of this text is able to either recognize basic shapes of graphs, for instance, a linear function, ax plus b, where a is slope. So it's the same as saying f of x equals mx plus b. It's just the same thing. B is still b, but a is our slope, and b is our y-intercept. So it's the same thing as a normal linear function. The graph of linear functions have the following characteristics. The domain is a set of all real numbers. As long as the slope isn't 0, then it's just a straight line. When 0 is not equal to 0, the slope is the range of all real numbers. So it's just pretty much saying as long as it's not like this, the slope will, or the range, sorry, not the slope, the range will be all real numbers. The graph has an x-intercept and a y-intercept. So what we can do is we can use some properties of functions. So we can write a linear function given that f of 1 is equal to 3 and f of 4 is equal to 0. So what that's really saying so f of 1 equals 3 is really the same thing as saying that we have a point 1 comma 3. And when it says f of 4 is equal to 0, it's really saying that we have a point at 4, 0. We have a point at each one of these here. So if we remember back to what we did a few days ago, we can use the point slope form. So we'll find slope first and then plug it into this form here with one of the points, and we can find the equation of the line. Now the slope is going to be y2 minus y1 over x2 minus x1. So for this here, 3 minus 0 is 3. 4 minus 1 is 3, and 3 divided by 3 is 1. That's kind of nice. Now we plug the slope in. Now I can pick one of these 2 points. It really doesn't matter which. Let's do 4, 0. 0 for y, 4 for x. Well, y minus 0 is just y. 1 times x minus 4 is just x minus 4. So our equation is y equals x minus 4. And that's all we have to do for this here. Now we could have chosen the other point, which was 3, 1. And then y minus 3 is equal to 1 times x minus 1. So we'd have y minus 3 equals x minus 1. Make sure I got the right point. 3, 1, yes. Yes. That's a little weird. Let's see, something happened. Let's back up for a second. Make sure I did that right. 4 for x, 0 for y. Okay. Woohoo, this is awesome. I'm glad I spotted this. So let's back up and let's see where I went wrong, because I already figured it out. 3 and 1. What did I do? I connected the wrong numbers. So this should be 1 minus 4, not 4 minus 1. It's the other way around. So we'd still get 3 on top, but we would get negative 3 on bottom, which gives us a negative 1. The slope should be negative 1, and I just realized that. I'm glad I did both equations, both lines. So we do y minus 3 equals negative 1 times x minus 1. So here y minus 3 is equal to negative x plus 1. And at this point here, we can add 3 to both sides. And we get the equation y equals negative x plus 4. Now let's do it with the other equation. Y minus 0 equals negative 1 times x minus 4. So the y minus 0 is just y. Now we multiply through the negative, we get negative x plus 4. Okay. Now we get the same one. So switching up those y values, or the x values here, will really change everything. So again, when we do the slope, they have to match. It's an easy mistake to make, so you just need to be aware of it and watching for it. So they did this here. So again, they got the negative 1 like we did on the second try. So it still works, and we go through and we get our equation. And then we could graph it on a graphing calculator or do it by hand. Either way is fine. Now, if it's just f of x equals a number like c, then it's a constant function. It's a straight line. The domain is all real numbers, but the range is going to be whatever that single value is. Now, the squaring function, what they call a squaring function, we have called a quadratic in Algebra 2. So the graph of a squaring function, f of x equals x squared, is a U-shaped curve with the following characteristics. The domain is all real numbers. The range of the function is a set of all real numbers, all non-negative numbers, negative real numbers, and the function is even. The graph has an intercept of this. Now, this is not talking about with any type of transformations, moving it up, down, left, right. It's only talking about this basic f of x equals x squared. It's only talking about that one there. The graph is decreasing on the interval of negative infinity to 0. So what that's saying is as we come from the left, the function, the y values are going down. And as soon as we hit 0, they start going back up. So it's increasing on the interval of 0 to infinity. So if a function is decreasing along the y, or it's going down on the y, it's considered decreasing. If it's going up, it's considered increasing. If it's staying the same, it's considered constant. Now, this graph is also symmetric to the y-axis and has a relative minimum at 0, 0. Actually, we would consider this a actual minimum value, but we'll get more into detail into that on a later date. Now, the next thing we're going to cover is cubic, square roots, and reciprocal functions. Now, we're not going to look so much at any of these here in particular because we've done these before. You've covered these before. The graph of a cubic function, f of x equals x cubed, is the domain is all real numbers. The range is the set of all real numbers. The function is considered odd, and its graph has an x and y intercept at 0, 0. Now, at 0, 0. The graph is increasing all the way because it's continuing to go up. From all the way, if we come from the left and go towards the right, it is continuing to increase. At the middle there, at the origin, it seems like it's not. It's just increasing at a very, very small amount. It's just hard to see. But it's increasing across the whole thing. Now, the square root function has the following characteristic. The domain is a set of all real negative numbers because, again, we cannot plug a negative number into this radical as it is. If I plug -1 in, it won't work. I can't plug in -0.1 because a negative will not work. The range is the set of all non-negative real numbers because, again, for an even root, a square root, we have to plug in positive values. We will get positive values out. And the graph has an intercept at 0, 0, and it's increasing on the interval of 0 to infinity. Because when we look at this here, we can see it's increasing from 0 to infinity. And I didn't say this earlier, but when we talk about increasing and decreasing, we're only talking about the x values. We're not talking about the y. We're only talking about the domain in which it's increasing, decreasing, or remaining constant. The reciprocal function, 1 over x, has the following characteristics. Well, it's the domain of the function is negative infinity to 0, comma, 0 to infinity, because at 0, we would be dividing by 0, because if I plug 0 into this function, 1 over 0 will not work. The range is the same thing, because again, we will not get a y value out when x is 0. The function is considered odd. The graph does not have any intercepts, and the graph is decreasing on the interval of negative infinity to 0 and 0 to infinity in its respect to the origin. So it might seem weird, but if we look at this here, as we go this way, the y values are getting smaller. And then as we're continuing to move this way, they're still getting smaller. And at 0, it's almost like it jumps from one to the other, so they don't consider it increasing at that point. It's still going down. Step and piecewise function. Now, this is the main thing we're going to focus on for this lesson here is a step function. A step function is the greatest integer less than or equal to x. Some values of the greatest integer function are as follows. So the step function of -1, the greatest integer less than or equal to -1 is -1. So -1/2, the greatest integer less than or equal to -1/2 is still -1. So 1/10, the greatest is less than or equal to the greatest integer. Well, the greatest integer less than or equal to 1/10 is 0. So 1.5, the greatest integer less than or equal to 1.5 is 1. 1.9 goes back to 1. And the graph has this stair step, I'll scroll down, like this here. So it's always kind of dropping back down. So anything from 0 to 1, and not including 1, would be at 0. As soon as we hit 1, we jump up to 1 on the y, and it goes in this form here. Now, when we take that, we don't take it until we're completely done with it. So let's look at this here. So if I want to find this, so f of x, let's do the first one, -1. So -1 plus 1. Well, the stair step, the greatest integer less than or equal to -1 is just -1, and -1 plus 1 is 0. So I really should have written this as f of -1, but that's beside the point. Now our next one would be 2, so f of 2. So our stair step or step function 2 plus 1. Well, the stair step of 2, the greatest integer less than or equal to 2 is 2, and 2 plus 1 gives us 3. And last but not least, we're going to have f of 3/2. So our stair step of 3/2, so the biggest integer less than or equal to 3/2 is, well, 1. And 1 plus 1 gave us 2. And that's all we have to do here. Now on these stair steps, make sure you do everything inside that kind of stair step, that double bracket first. So any addition, subtraction, multiplication, powers, do all of that first. And then once you get that number, a number, then you will do the stair step. So the first one here, so we got -1, and then we got down to 0. And for this here, for 2, when we stair stepped it, we got 2. 2 plus 1 is 3. So 3/2, as we saw here, stair step down to 1. 1 plus 1 gave us 2. And that's kind of it. So we'll do one more example of this here. So let's say f of x is equal to the stair step of 2x minus 0.5 plus 3. And we'll do two numbers, f of 2 and f of 0.3. So f of 2, what we're going to say is inside our stair step, we'll have 2 times 2 minus 0.5. And then outside we have plus 3. So what we're going to do first is everything inside here first. So we'll do 2 times 2, which is 4. Well, 4 minus 0.5 will give us 3.5. Well, our 3.5 stair step, well, the greatest integer less than or equal to 3.5 is 3. Well, 3 plus 3 is 6, and that's it. Now, if we do it with 0.3, so our stair step, 2 times 0.3 minus 0.5 plus 3, ran out of space. Well, 2 times 0.3 will give us 0.6 minus 0.5 plus 3. Well, 0.6 minus 0.5 is just 0.1. So the greatest integer less than or equal to 0.1 is 0. And 0 plus 3 gives us 3. So we simplify what's inside the stair step first, then do our stair step, and then simplify from there. And then we're done. And that's it. That's all we're going to do for this here. Now, we have some parent functions. I'm not going to go too in depth with this because we've already covered parent functions before, how they transform, how they move. And they all look like this here. These are the basic functions. And here we have a few more because we include the stair step, the reciprocal, and the radical. But there's nothing really too uncommon with those here. So our homework assignment for this here is on page 65, problems 27 through 30. So you'll get those done and turn that in, and that's all we have to do for